Okay, so we're looking at graphs then. Graphs of sine, cosine and tan. You need to be able to identify, sketch and use these three graphs. So let's get the lesson objectives down, and then when you're ready hit play again and we'll look at these three graphs. So you're going to be making some notes and some sketches, and these are graphs you will be familiar with from GCSE. Sine theta repeats every 360 degrees and it crosses the x-axis at these points, minus at 180, 0, 180 and 360. Max 1 and minimum value of minus 1. So when we sketch it, max and min values, those are positive on the x-axis or the theta axis and negative. So sketch them, write the properties down. When you're ready hit play and we'll look at the cosine curve. It is good to note that if you take a value say of 1, you can have an answer here of 90 or of minus 270. Similarly, if your value is minus 1, you can have a minus 90 here or 270. So depending on what value you get here, between 1 and minus 1, you can have a range of values, of different values. Right, let's look at the cosine curve then. Cos theta, it also repeats every 360 degrees and it crosses the x-axis, minus 90, 90, 270, 450. So you can see it's a mirror image on the y-axis, and that's what it looks like there. So hit pause, write the properties down and sketch the curve. You just want to sketch, it doesn't have to be perfect. Okay. When you're ready, hit play again and we'll look at the tan curve. Okay, and our tan curve, slightly different, repeats every 180 degrees and crosses the x-axis at the following points, minus 180, 0, 180, 360. It's not one we sketch as often because it repeats every 180 degrees. So it's much easier to find values. It has no maximum or minimum value. It continues forever, and it has vertical asymptotes. So that means it tends towards these lines, it tends towards these values, but it never actually attains them. So if we sketch it, so that's our tan graph, that's what it looks like, and our asymptotes are these lines here. Now they extend further than the dots shown there. So really, ideally, we should extend them. I'll just change the color of the pen here. So they should extend infinitely. And the curve tends towards them, but it never actually attains the value. So it never attains minus 90, but it goes towards it. And that's what our asymptotes look like. So our y graph is asymptotic at the values minus 90, 90, minus 270, 270 and so on. So as before, hit pause, make some notes. When you're ready, we're going to look at an example. Okay, so you need to be able to recognize and sketch these graphs at any time. So sketch the graph of y equals cos theta in the interval minus 360 to 360. So first, you need to sketch a grid. My x and y axes. Makes it a bit easier. And now, switch back to pen. So cosine curve, but any of these graphs, you need to be able to sketch them with ease. My axis isn't quite long enough. And a mirror on the other side. There we go. So that's a maximum of 1, minimum of -1. It's our origin. Cos curve. Cos theta, which means this is going to be theta. 90, 180, 270 and 360. And on the other side is just negative. Minus 90, minus 180, minus 270, and if I extend this, minus 360. Good. So you need to be able to sketch that. So hit pause and draw that now. When you're ready, hit play again and we'll look at another example. Okay, this time we got our example says sketch a graph of y equals sine x in an interval of minus 180 to 270. So let's do that to start with. Make sure this line is long enough this time. Okay. So back to the pen again. Right. So y, I won't put theta there yet. Let's just see how this goes. So sketch our sine curve. Now that's 0. We've got 90 here, 180, 270, and that's all we're required to go up to. And the minimum here is minus 180 and minus 90 there. So that's part A, y equals sine theta. For part B, or II, it says sine theta, sine of minus 30 is equal to minus 0.5. Use your graph to determine two further values for which sine of x equals minus 0.5. Well, maximum is 1, minimum is minus 1. So minus 0.5 is about halfway here. So we need to sketch a line all the way through to find out where it intersects the curve. So let's draw a line then. Just choose a different color. So about halfway there. So we've got additional values. Let's change that back to red. So the first one that we're given, that's minus 0.5. First one we're given here is minus 30. We can see it repeats though over here. So what's that value? Well, because it's a symmetric curve, if I go from here to here is 30 degrees, which means from this, where it intersects the x-axis to this point is also 30. So that's 180 take away 30, so that's going to be minus 150. And if I look on the other side, positive value here, where it intersects again. By symmetry, this point here is 30 degrees away from 180, so that's 180 plus 30, which is 210 degrees. So the additional values that implies then that x is equal to minus 30, which is that one there, minus 150, or 210. Good, so sketch the curve, hopefully a bit better than mine. Once you've done that and copied the answers down, then I've got some classwork for you. Not too many questions on this exercise. So hit pause, copy, when you're ready, hit play again. Okay, so exercise 9F is on page 194. And there are only 4 questions there, so have a go at all of them. Good. I'll attach the questions to the assignment.